To receive the official classification as an El Niño event, scientists from official organizations such as the National Oceanic and Atmospheric Administration monitor the sea surface temperature anomaly, which is to say the departure from average temperature in a region of the ocean, the Pacific Ocean, that is off the west coast of South America. If this sea surface temperature anomaly in this region is trending at or above half of a degree centigrade above the average for 5 consecutive 3-month periods, then an El Nino is officially called. If the sea surface temperature in that part of the Pacific appears to be trending at or greater than 2 degrees centigrade above the average, then it's dubbed a super El Nino. And the region of the Pacific that they watch is, if you were to trace the trend of the Hawaiian Islands from their northwest point down south-southeast, and observe that trend all the way down to the equator, that is the region that they use. In what we think of as the effects of a typical El Nino, here in the U.S. Southwest, we would usually expect a wetter winter, more winter precipitation. And in the Pacific Northwest of the United States, you would expect a warmer, drier winter. Australia, it typically implies, an El Nino typically implies a dry winter. And again, this is because of that shifting of the whole convective pattern in the atmosphere east over the Pacific, and the stranding of that large package of warm water off of the northwest coast of South America, which supercharges the atmosphere with heat and moisture, and has a propensity to generate more storms. In order for the effects of El Nino to be felt inland, the atmosphere actually has to couple with what's going on in the ocean, because remember, the determination of El Nino is a oceanic matter. However, the Walker circulation, which is the circulation of air along the equator in large convective cells from east to west across the Pacific, in a typical El Nino, those trade winds will stall or even reverse, and the entire pattern will shift eastward. So what'll happen is you'll get, instead of a large convective cell moving up along the oceanic continent or northern Australia, that convection column will shift east over the east central Pacific off of the coast of South America. What this does is it creates a massive low pressure over the ocean there and strands a body of warm water off that coast. And this warm water is often the source of moisture and warmth that charges the atmosphere above it and gives us what we think of as a classic El Nino effect.